Hey everybody, let's talk about number 3. Hopefully you've read the problem already and you know that this is dealing with the number of steps that we take per day. So there's going to be one column of data, and that column of data should be the steps. Since it's the steps, we know that we are since it's one column of data, we know that we're either dealing with a one sample proportion test or we're dealing with the chi-square goodness of fit test. If you look at this problem, you see that it gives us a whole bunch of proportions. It gives us the proportion for people that take few steps, and then the proportion for those that take a moderate, the proportion for those that take many, and the proportion that take very many, right? So 1, 2, 3, 4 proportions. That means that we have a set of proportions rather than just one, and this is going to be a chi-square goodness of fit test. I'm going to go ahead and copy my formulas again, just because I find it to be helpful. And, oh, that was me. That's fun. Look at this. It's like Klein Inception. He is so smart. Anyway, sorry. That was annoying. Let me shrink that down. Okay. So we're going to need a pivot table again. Let's highlight the data. I should emphasize that you don't want to highlight the whole column. You just want to highlight the part that we are dealing with here. And then I'm going to come over here and pivot table on an existing sheet. And why not? We can go ahead and put it right here. Boop. And okay, there we go. And the data that we're going to want in this case are in the rows. We can say how many steps do you get per day, and then we just want values for that. So values, how many steps do we get per day, and it's giving us the counts. Now these data that you're looking at right here, these are the observed counts. Right? So there's our observed counts. Let's talk about, this is a chi-square goodness of fit test. And we're going to need some hypotheses. Our hypothesis number 1 is going to be that at this school, the number of steps we take is similar to the distribution in the rest of the country. And then our alternative is going to be that it is somehow different. Okay, so let's start with this one right here. The BHHS step distribution is the same as the rest of the country. And then the alternative is going to be that the BHHS step, I don't know why I'm capitalizing that, distribution is somehow different than the rest of the country. Okay. Once again, alpha is going to be equal to 0.05. Here we go. Now, the data that we need, we're actually going to get from messing around with this table. So I'm going to fill in the proportions that were given to us. They said that few steps was 20%, that many steps, that moderate steps was 0.45, that many steps, let me check this, many steps was 20%, and then 15% was very many steps. So nationally, this is the distribution. One thing that can be a little aggravating with the Google Sheets here is you'll notice how it didn't put them in order. I would prefer that it went few, moderate, many, very many, because that's like a logical order. It's not going to do that for you because it's doing this alphabetically. Okay, so now what we need here is the expected counts. And the expected counts are just the proportions times the 71 people. So we would expect that 20% of these 71 people take few steps. So we would expect 14.2 of them. We got 21, so there's more people that take few steps than we would expect. If you do this, if you lock that D7, the location of our sample size, then you can just copy and paste to get the rest of our values. So there's your expected counts. And then here, the next thing we need is our partial sums. Recall that our partial sums are taking the observed, subtracting the expected, squaring it, and then dividing by the expected. So we're using this formula right here. So the first one is going to be observed minus expected squared divided by expected. And then I'm going to paste that formula here and here and here. And I always like to look at this and see where the big numbers are. So the biggest number here is the few. The second is the very many. The moderate is pretty small. What that means is that as far as the moderate goes, we're not differing from what you would expect very much. But with the few and the very many, we are more. Okay? So that's the data that we need. So, phase 2 is to identify the type of study. It's a population survey. And all the data that we need to work with is already up here. So we can move to phase 3, where we just need to check the conditions. And the condition is that all of the expected counts are at least 5. If you look at our expected counts, boom, 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 boom. Okay, we're good there. So all expected counts are at least 5. The reason you need to check that is that the chi-squared distribution doesn't work, or in other words, we can't calculate the p-value unless we have that. All right, so the next thing that we're going to do is get our value of chi-square. That's the x-square looking thing. And it's just going to be the sum of the partial sums here. So it ends up being 8.671. And our p-value is going to be equal to, you type in chi sq dot dist.rt right here. And then you tell it that this is my value of chi squared. And then your degrees of freedom will be the number of categories minus 1. There are 4 categories, so I'm going to put in right here a 3. So our p-value is a little less than 5%. Conclusion, we're going to reject the null hypothesis because the p-value is smaller than 0.05. What kind of conclusion can we make? We can say the step distribution at BHHS differs from the rest of the country. Anytime you do this, I want you to go a step further and explain how it differs. So I think what we would want to say here is that we have far more students that take few steps and far fewer students that take many steps, right? Because this 21 is bigger than we would expect, and the very many is smaller than we could expect. So maybe on average, we could say on average, BHHS students are taking fewer daily steps than the population at large, or the rest of the country.